A transformer has a percentage resistance of 2% and percentage reactance of 4%. What are its regulations at power factor 0.8 lagging and 0.8 leading respectively? So here what is given? The per unit values of resistance and reactance are given. So R, small r we will take. So this is equal to 0.02 per unit and X is 0.04 per unit. We are just taking out the percentage and writing in terms of the decimals, right? Then what is the expression for voltage regulation? This is given by R cos phi plus or minus X sin phi. Plus is used for lagging power factor and negative is used for leading power factor. But if the angle itself is taken as negative, then you simply don't have to worry about this negative sign, okay? But here we will take only the magnitude. So first if you take power factor of 0.8 lagging, then voltage regulation is equal to 0.02 into 0.8 plus 0.04 into 0.6. How do you get 0.6? It is root over 1 minus 0.8 square. So this if you calculate, you're going to get 0.04. And if you want in terms of percentage, then percentage voltage regulation is equal to 4%. This is for 0.8 lagging. And what about 0.8 leading? Here you have to take the negative sign. So VR is equal to 0.02 into 0.8 minus 0.04 into 0.6. This you are going to get minus 0.008. So in terms of percentage, you can get minus 0.8%. A 2-winding 220 volt by 110 volt 1.5 kVA transformer is reconnected as a 220 by 330 volt auto transformer. It is re-rated as. So here we have to find out the kVA rating of the auto transformer. First we will try to draw the 2-winding transformer. So on one side you have 220 volt and the other side you will get 110 volt. And what will happen if it is reconnected as auto transformer? The primary side is 220 volt, that is not changing. So this is 220 volt. Now if this is the dot polarity, you can see that on the secondary side you have 220 plus 110, 330 volt. So it is a additive connection, right? So the dot polarity is going to be like this. Here you have dot and here you are going to have dot. So that the voltage you are going to get 330 volts on the secondary side. Now one thing you have to remember is the current through each of the windings, the rated current will not change. Whenever there is an auto transformer question, you just have to remember that one small point, okay? So if you take this transformer, it is given that the kVA rating is 1.5. So you can write as 1500 volt ampere, okay? So this is equal to, now here you can see that this is common winding, this is not the common winding. So we will consider the winding which is not common, okay? So that means the 110 volt winding. So that current if you take as I2, then the same current I2 should be flowing in the auto transformer as well in the rated condition. So we will find I2. Once we know I2, then I2 into 330 will give you the voltage, volt ampere rating of the auto transformer, okay? Now 1500 will be equal to 110 into I2, right? So 110 into I2. So this implies that I2 you can write as 150 by 11. So now you can get this rating. This is equal to I2 into 330, it is equal to 150 into 330 divided by 11. So you are going to get 4500 volt ampere, or in terms of kVA if you write 4.5 kVA. So this will be the new rating. A single phase 50 kVA 250 volt by 500 volt 2-winding transformer has an efficiency of 95% at full load unity power factor. If it is reconfigured as a 500 volt by 750 volt auto transformer, its efficiency at its new rated load at unity power factor will be. Now if you remember from auto transformer, the losses is going to be same even when the 2-winding transformer is reconnected into an auto transformer, right? Losses will remain same. But what is happening? The output kVA is going to change. In auto transformer, it is going to increase. So what will happen to the efficiency? Efficiency will also increase. So you can write down, as a 2-winding transformer, the efficiency is given as 0.95 if you take the decimal. This means that output by input is equal to 0.95, and if you write the input in terms of the losses, output plus losses, this is equal to 0.95. So the losses value you can get from the output and efficiency as output into 0.05 divided by 0.95. This will be the losses value. Now what is the given output of the 2-winding transformer? It is given as 50 kVA. So you can write that output of 2-winding transformer is given as 50 kVA. Okay, so you can get the losses. So this is equal to 2.63 kVA. This is the 2-winding part. Now we will switch to the auto transformer part. Okay, so first we have to find out the rating, the kVA rating. So if you draw the 2-winding transformer, on one side we have 250 volt and the other side it is given as 500 volt. And what about the auto transformer? The auto transformer primary has 500 volt, and what about the secondary? The secondary winding is given, secondary voltage is given as 750 volt. So this is additive connection. So here you have 250, so that the total voltage you are going to get as 750 volt. Now in order to find out the rating, which current is more useful for us? This current. So we will take this as I2. So this is the current through 250 volt winding. Here 250 volt is the primary winding. So this current is going to be I2. So from here you can write the output kVA, which is given as 50 kVA. So 50 into 10 cube is equal to 250 into I2. So this implies that I2 is equal to 200 amperes. From here you can get the rating of the auto transformer. 750 into I2. This is equal to 150 kVA. Okay, so now we have the value of losses, and now also we have the output. So you can find out the efficiency as output by output plus losses, and here output is 150 divided by 150 plus 2.63. This, if you calculate, you are going to get 0.982. Okay, so that means in percentage you are going to get 98.2%. Two single phase transformers T1 and T2, each rated at 500 kVA, are operated in parallel. Percentage impedances of T1 and T2 are 1 plus J6 and 0.8 plus J4.8 respectively. To share a load of 1000 kVA at 0.8 lagging power factor, the contribution of T2 in kVA is. So first we will write down the given information, right? So for transformer T1, the rated kVA is 500, and similarly for transformer T2. So S2 is also equal to 500. Then the percentage impedances are given, right? That means Z1 is equal to 1 plus J6 per unit, and Z2 is equal to 0.8 plus J4.8 per unit. And finally the load kVA SL, this is given as 1000 kVA at 0.8 power factor lagging. So this is 0.8. Now we have to find out the contribution by T2. So one thing that you can do here is you can take this as S1R and S2R, right? So as to note the rated values. These are not the actual values that the transformers T1 and T2 are delivering. These are the rated values. We have to find out what is the actual kVA that is delivered by T2. We know that S2 conjugate is equal to SL conjugate into Z1 by Z1 plus Z2. Now SL conjugate, you know the magnitude 1000 and you know the cos phi, so you can find out the phase, okay, and it is given as lagging power factor, so accordingly you can give the phase. So what will this be? This is equal to 1000 kVA angle of cos inverse 0.8, you will get 36.86 degrees. But here note that this is conjugate, okay. Since it is lagging power factor, the angle should actually be plus 36.86, but since it is conjugate, the angle will be just reversed. So minus 36.86 into what is Z1? 1 plus J6 divided by 1 plus J6 plus 0.8 plus J 4.8. So this if you calculate, you are going to get 555.53 angle minus 36.86 degrees. Okay, so this is the conjugate of S2. What do we want? We only want the kVA. So we are not concerned with the phase. So the apparent power is going to be mod S2 conjugate, which is 555.53 kVA.